Now that we have covered the graphics library, remember that I can still go back and add some more functions in, or if you decide to download all of the materials, you can go ahead and try and generate some yourself. Now the next one we're going to move on to is the largest library that I've generated so far, and that is the mathematics library. Now I'm going to split this into separate sections. So in this video, we're going to look at something I've just called the basic mathematics library. In the next few videos, we will cover how we work with vectors, we will cover matrices, and we will also cover complex numbers. But for the moment, let's just go through some of the functions here, and it's going to be quite a quick video because we don't really need to labour it too much. We've seen how we're able to pass values into subroutines, and the values come out the subroutine back into a position in memory. And it's nothing different here as well with these particular functions. And I think I've got three or four sitting here. So the first one we're going to look at is a useful one within mathematics, and that is a power function. Now another thing to remember here is all of these functions we're looking at are purely for integer values. We don't have the functionality, or I haven't shown you the functionality to deal with the decimal places. We'll get to that on a different video. So if I wanted to generate the power function, which is ax to the power of n, so for example 2x to the power of 3, a half x to the power of 8, 9y to the power of 18, that sort of thing, then we can generate it with this little bit of code here, and I've put a little example here. So in this example, we're going to pass in this order a, x and n, and then we're going to jump to the subroutine math underscore power, and it's going to work out the value a times x to the power of n, and it will return it back, and then we can onto the stack, and then we can pop the result into this memory location called result. And there's an example here. If we had 2, 2 and 3, it would be 2 times 2 to the power of 3, which is 2 times 8, which is 16. So that's self-explanatory. We could copy this bit of code here, and we could stick it in an ASM file, and we can generate the power function. Now another function we're going to look at here is the modulo function. So what we do here is we take two inputs. In this case I've called the inputs A and B, and we divide A divided by B. So for example, if A is 10 and B is 3, then it's 10 divided by 3, and the result of that is 3 remainder 1. So the modulo is the remainder after the division. So in this here the answer is 1. So we just have to pass push the two values onto the stack, jump into the subroutine, and the subroutine will run through and it will return the modular, and we can put it into result. So straightforward. See, this is the beauty of spending some time earlier looking at subroutines and how the subroutines worked, because we can quickly go through these now. Now another one is a factorial. So an example here, 5 factorial is 120, so it's 5 times 4 times 3 times 2 times 1, and it gives you 120. Now the factorial is an interesting one because it was the first recursive function which I produced, and it's a nice one to have a look at if you want to understand recursion. So we're going to put in a value of n, so we're just working out n factorial. We jump to the subroutine, it works the value out, and then we pop the value off the stack on into result. Really easy. So the final one we're going to look at is the square root function. Now it's just come slightly off of the screen here. So if you bear with me just a second, I should be able to get it back onto the screen for us. I'll just shift it up a bit. There we go. So again, the square root, I think we all know how to work out the square root of a number. So the square root of 49 is 7. Okay, so it's positive 7. So we're going to push the number n, which we want to work out the square root of, in this case 49, onto the stack, jump to the subroutine, works out the square root, we pop the result back into the memory location called result. So those are the basic mathematical if you like, functions which I have generated. We could generate more, we could keep generating them, but in the end I have to a certain time limit, and if there's any more that need to be generated, you know, that's the beauty of the courses. You can take the course, you can run with it, and you can generate whatever mathematical functions you think are going to be useful to you. So that's really all for this video. We don't need to even go in and have a look at it in terms of the actual CPU, because we've seen it before. We just go in and load it and it will run it, and it will give us our result, and it will save it to memory. So let's move on in the next video, and we'll look at the idea of vectors, and there's a little bit more involved and some more new stuff in the next video. So thank you for listening. I will get you on the next video. Goodbye.